Namaskar, welcome back. So last lecture we were talking about the one of the most important landform, commonly found landform, I would say, that is your river terraces, and we also discussed about how we will classify the terraces, because terraces in general sense it is an erosional feature, or it is when it is it develops because of the erosional process, but we classified that as an aggradational and degradational terrace. How we classify that part we have discussed already. Along with that, we also discussed that how the river will behave if we are having the variations in the discharge, in the slope, and even the roughness, okay, and sediment bed load. So how river will behave, either it will erode or it will get into the depositional domain. Now, further, this we have already discussed about the gradational terrace, degradational terrace, paired and unpaired terraces, and based on the cut and fill process and incision of the alluvium in the bedrock, how we will classify the terraces, whether it is a gradation or degradational terrace. This part also we discussed, and degradational terrace mainly we also term that as a strat terrace. We also saw a couple of examples of strat terrace in Himalayas. Now we will move further and we'll look at quickly about the drainage basin and drainage pattern. Mainly we will be focusing on drainage pattern, because drainage pattern also tells us about the lithology, and if the drainage is been controlled by tectonic activity, that also we can infer based looking at the drainage pattern also. So, drainage basin area of land that contributes surface water to the stream, identified based on topography, also called watershed or catchment area. Okay. So, this is this based on the image what you have here. You can classify uh, or demarcate the drainage basin, and that will be done based on the drainage divides. Okay. So, based on the slope and the ridge line here, that will mark as in your drainage divide, because on either side these small streams are flowing in opposite directions. Okay. So, these streams are flowing in this direction and then going and meeting the main stream. So, this portion, for example, which has been shown here, this large one, so this will mark your drainage basin boundary, and if you complete that, then you will have the drainage basin. So you can have multiple drainage basins also. That is what we call sub basins, or and collective sub basins. You can have the major basin of a higher order stream. Okay. Now, how the drainage is formed actually, basically uh, the how the drainage system evolves. Okay, that is one part we have already discussed in the beginning. But if you see, uh, I just want to share this because uh, in this photograph is from an line in Andaman. So on a very small scale, we were able to see the formation of the landforms. Okay, and that what so here two parameters are there. One is your topography is there, where you have a flat surface over here, the side is flat, and then you have a slope here. So waves, ocean wave comes and goes back here. Now while going back, that is traveling along the slope, what are the landforms that it develops? Okay, so this is the short of in what we have already learned also in previous lecture, that is your delta, and then you have meanders here, and then also the formation of terraces. So these are the small terraces which have been formed here. Along this, there is another terrace which is formed here. Okay. So multiple terraces on the inner side of the bank, and this side is marking your erosive bank. Okay, and that what we were discussing in the previous lecture also. This is an erosive bank. So here also you have meander, and then so this part is an erosive bank actually. Now, looking to other portion of that of these streams, what we are able to gather is that we have an unconfined area, and then we are able to see some sort of bars here, and that is what we have, the braid bar and delta system. Okay. So again, on little bit more further here, this whole bank is an erosive bank, and that is the reason why we see a cliff over here. Okay, and this is a depositional bank here. Close up of that, if you see, then you will be able to fix up the looking at the terraces. So this is on a small scale, but we have also looked at example from BIAS where we saw the multiple terraces T0, T1, T2, and all that. Okay. Now, in one of my slide in previous lecture, I was talking about that alluvial channels are sensitive to tectonics. Okay, we have a separate lecture on this also, that how, and but we will briefly discuss this part here. So if you have like again, the channel pattern can change based on what we have discussed in previous lecture also, that if you are having sediment bed load is changing, if you are having like velocity changes, slope changes, then the channel pattern will change. Okay, and channel will get into the erosional or a gradational phase. Okay, and of course erosional features will be different, the gradational features or the landforms will be different. Okay. Now here what we see is that we have straight, and then we have meander, and then braided. Okay. So the channel pattern which has been shown here in the upper figure A here, what we see that if you are having the bed load, okay, then how you will be able to see the straight channels, meandering channels, and the straight channels. Okay, mixed bed load, then what we will be able to see mixed bed load. Of course, in one of the slide we were also discussing about that you will have finer deposits and coarser deposits in the respective side of the meanders, depending on that whether it is erosive or depositional side. Okay, and then we also learn about the anastomosing and braided system. Now, if you subject these channels to tectonic activity, okay, then you may see a sort of an change in the channel pattern. So if you are having like uh, it can change from straight to meander or from sinus to anastomosing. That is possible. Okay, so channel patterns can channel patterns can change because of tectonic influence or tectonic perturbations. Okay, so this says the classification of channel patterns. A, channel form classified according to channel pattern: straight, meandering, braided, and anastomosing. So we have this three. Okay, braided, straight you are having, meander, and anastomosing is there. And the sediment load, or you are having suspended load. Okay, you have then suspended load and bed load mix. You have, that is your mixed bed load. Okay, and then you have clearly bed load actually. Okay, so suspended, mainly you are talking about the very finer deposits which have been carried, and in bed load where we say, then we are talking about the coarser bed loads. Okay, coarser sediments. Okay, and that is typical of your braided system also. Okay, and then further there's an B, a classification of river pattern that indicates single channel and branching forms. Okay, so straight can result into your uh, partially braided one, and sinus channels will can result into your branching rivers, and single channel rivers can result into your. So this is just to explain about the that what is the about variations you can see in the terms of the channel pattern. But we'll come to that how the channel patterns changes. Okay, from if you are having, for example, straight channels, then can get into the meanders or not. One of the example we will discuss in this lecture itself, from Himalayas, the foothills of Himalaya. Now, you can also classify the channels based on their forms. That is, one is the consequent streams. Okay. Now, consequent streams uh, or a stream flows along follow the slope. Okay. Developed development of slope may be due to uplift, or maybe due to tectonic uplift. Okay. The second one is subsequent channel. Now, this is flowing along the slope where you have the beds are also dipping in this direction. Okay. So, dip is in this direction. So, and this slope uh, could be a tectonic slope also. Okay. Whereas another one is subsequent stream is not exactly following the slope. It is flowing like uh, across. It is falling across the folded, or we can say against the slope. Okay, mainly. So a stream that develops later on, carving the softer rocks and flows almost right angle to the original slope of the land. So original slope, if you look at, then this direction is the slope, and this direction, the stream is flowing almost perpendicular to that, or right angle to that. So that is termed as subsequent streams. Then if the stream is crossing your folded stratas, or fold, we can say. So this is the typical what we call fold. So if it crosses the fold, so of course you have incision here. Such streams are known as antecedent streams. Okay. And then another one is superposed streams. Again, they are not exactly following the slope, but they usually cut across the inclined stratas. Okay. So these are some examples which you can try to uh, use for classifying the streams. Okay. So mostly the streams which are crossing the Himalayan front are antecedent streams, because they are cutting across the folds actually. So Himalayan foreland before it debouch into the Himalayan foreland. Okay. Now, stream piracy is also one very important aspect, which most of the time we see that this could be due to tectonic uplift and all that, but this could be due to the drainage development. Okay, or as the drainage evolves towards the headward side, it may result into the capturing of the streams or the drainage basin of another adjacent uh, drainage basin. Okay. So that is very much possible. Okay. So because that is the process mainly remains that what we have discussed is the headward erosion. Now this headward erosion, if it has been rapidly like it is increased, or it could be due to the tectonic uplift also. So for example, you have the escarpment here, and then because of the uplift, the drainage divide has been formed here. Okay. So you have the basins on either side of um, the ridge line. Then slowly the erosion, as we see that the basin will evolve headward side. Okay. So it will develop in or evolve in the upstream side, that can result into the river capturing. Okay. So once the divide is breached or eroded, then it can have sort of an capturing of the drainage of the other side. Okay, and that is what we called uh, uh, river piracy. Okay. Now, in one of the lecture, we also looked at that if you are having digital elevation model, that based on that you can extract the streams. Also, you can also look at the terrain and easily understand about the drainage pattern. And based on the drainage pattern, you can also classify or at least have a preliminary interpretation of the what type of landform you are looking at, structural landform. Okay. So, for example, if you see the slide, then what we have is that this is your we have this is our Janauri anticline. Okay, this is your Janauri anticline. Now, if you look at this feature only, I'm not getting into the fault and all that right now, but I'm just trying to look at trying to show you the morphology of this area. Okay, so what how it looks like. Okay, so we have clear cut like the of Janauri anticline. In the center part, if you see, then you are able to easily demarcate that ridge line. Okay, so this is the ridge line here. There is another ridge line over here, and then further it goes like this, further like that. Okay, and then there is no drainage here. The ridge line goes somewhere like this here, and this portion goes somewhere over here. Not very sure here, but yes, okay, of course. And then further like this. Okay, so this is my ridge line. Of course, if we look at the cross section here, then you will be able to see that this is a very typical anticline. Okay, so this is an anticline. So and this is the center part is your ridge line. Okay, this is what we are looking at this point. This is the hinge point, or we can say the ridge line. This area is flat. There is no drainage. Much of drainage is developed. That also we can easily make out. Okay, this area is again flat area. Of course, drainage is there, but not as prominent as what we see on the slope. So streams in this region or along this in overall region of Janavary anticlines are flowing like this. Okay, so you have the streams which are flowing here in this direction, and then on this you have. So you can easily make out that this is a typical of fold. The limbs are dipping away from one another. Okay. So based on drainage pattern also one can identify the landforms. Now let us come to another portion. I'll show example from here, this portion. Okay. So next coming few slides we will talk about this also. If we look at this part here, this also again I'll be explaining there. But what we found was based on drainage, we were able to identify that this area is having a sort of a domal structures. Okay, and even on this also we saw a sort of a domal structure, and over here also. I'll come to that later on. So my point here was that based on the drainage pattern, what you see on the surface, you can identify and talk about your structures, geological structures. Okay. Now coming to this here, this is again the Janavary anticline. We are looking at in looking like from south towards north and in 3D perspective view. Okay. So this is the flat surface which I was talking about. Okay. And now if you see, you can make out easily that this is unfolded area. So in this portion which I was discussing in the previous slide, we were able to pick up that this is an warped area because of the drainage pattern. Okay, so streams are like we were able to pick up the streams which are flowing in different directions. So probably this is what we interpreted as an warped area. And of course, yes, this is an area of Kangra Valley actually. Now there are another part. There is another part also that based on like what we did, but I am not going to talk in detail about this part here because this itself has a very important points to be discussed when we are talking about the thrust fault environment and all that. But yes, the data which we are using here is to identify, like you can have the 3D perspective views. You can generate high resolution 3D perspective views and try to view the terrain. This is what we did for the portion in the central Himalaya, and we were able to pick up that there are very clear cut wind gaps. Okay, over here, which indicated that this Dapka river, this is Dapka river, and Dapka river flowed through this areas in the past, in during geological past, because of the growth of this fold here, that is what we have. We say Kala Dungi fold. Okay, and basically this is a fan area. So this get folded, and then so propagation of the fold in this direction was responsible of shifting these channels over here. Okay. This is the present day. Next, it will shift this and join. Uh, will be joining the, if I'm not wrong, this is the Kosi River, not the Kosi of Bihar, but so yeah, this is what we identified here. But I'll definitely discuss later on also this part. So based on the landforms, okay, which we were able to see, that is what we call the wind gaps, okay, because right now it's a quite wide channel here at the channel boundary, and which is almost sitting at an elevation, okay. Nevertheless, there is some stream, small stream has occupied this area because there is a slope available, and during the monsoon season, there will be inflow of this river of rainwater through these channels. Okay, but usually not like what we see in present in Dabka. So based on that, we were able to fix up that these are the different wind gaps, and they were developed at different uh, time frame after the, like, first got abundant because of the movement, and then the river started flowing through this one. Then this got disrupted. Then it started flowing through this one. Then this propagation, okay, continued during different earthquake events, and then finally what we see is this present day Dabka. And as I told in the previous slide also, that next earthquake, this will move further, and the Dabka will probably join the Kosi River. So these are the different type of uh, techniques you can use. Of course, this is a part of the remote sensing technique only, but you can use this different ways of illustrations and try to understand and extract the landforms, because landform extraction is very much important. Identification is very much important for us. Okay. Further, the drainage pattern, as I told, that we'll look at that in this area. So let's see, before moving to the one of the area from Himalayan foothills, but let us see that what exactly the drainage pattern tells us. Okay. So usually drainage pattern is the reflection of what we have, the underlying geology. Okay. This reflects the clear cut geology. So these are some very typical drainage patterns uh, seen commonly, are mostly you can see the dendritic pattern, rectangular pattern. Rectangular patterns will be in the areas where you are having fractures and joint. Then you have parallel drainages, trellis, annular, subdrainage, and many more patterns are there. Okay, like here also it has been seen few which are been classified, like so deltaic region you will see something like distributaries, and the rectangular patterns you will have a sort of enjointed patterns, then they will flow along that. Okay, then centrifugal, radial, you will have domal areas. Okay, trellis, homogeneous landforms will be there. Parallel drainage, we have seen that if they will be mostly along the slope. In folded terrains, you will see a trellis pattern. Okay, so the streams are coming and joining the trunk stream at the trunk stream at right angle almost. So these are because of the folded terrains will have softer and like you have uh, harder rocks or the softer rocks, then the softer material will be eroded, and that will result into the formation of this trellis pattern. Okay, so dendritic pattern, it will be more or less like tree limb. Okay, and you will see multiple small uh, low order streams which are joining in that. Okay, so it is like tree like limbs will be seen if you are having the trellis pattern. Okay, then as I told, the rectangulars you will have jointed joints and all that, so that can result into a typical rectangular drainage, and the drainages will be like it will not be in very straight, but the turn will be almost like in at right angle or so. Okay. Then you have trellis pattern, so you have resistive rocks and softer rocks. So less resistive rocks will be eroded, and that will result into the formation of your typical trellis pattern. And trellis patterns are indicative of your anticline and synclinal area, that is folded area regions. Okay. Then you have radial drainages, which usually show that the central portion is having some elevation. Okay. So that part is very simple and you can easily make out. Okay. Anyways, we'll stop here and we'll continue with a few examples in the next lecture. Thank you so much. Namaskar.